Example 1 in combining transformations. So we're given the graph of f of x here. So we've got these ordered pairs to work with. We're going to sketch the graph of y equals 3 of f of 2x. So this 3 means there is a vertical stretch. I'm just going to abbreviate that, say VS, vertical stretch by a factor of 3. So whatever the a value is. This 2 tells me there's a horizontal stretch by a factor of 1/2 because it's always the reciprocal of the b values. So what we're going to do is we're going to list the ordered pairs of x and y for our f of x graph. So our f of x graph here, we've nicely labeled these points. So we're just going to list them to work with. And now we're going to apply the mapping notation. So if we're going to look at the x is affected by the horizontal stretch. So we're going to rewrite this as 1/2 x. And then the vertical stretch is 3. So that affects the y coordinate. So we're going to say 1/2 x, and then we're going to say 3y. So we're going to cut these x values in 1/2, and we're going to multiply the y values by 3. And there is no other transformations on there. So then we'll plot those points. So I like to just do one thing so I'm not back and forth remembering if I'm multiplying by 1/2 or 3. So I do all the x values first. So multiply them all by 1/2. So you're cutting them all in half. 9/2, you can leave it that way. When you go to plot that, that's going to be 4.5. Multiply all the y values by 3. And there we have it. And all of these points fit on the graph. Sometimes because you're going to be multiplying by larger numbers, etc., you may not necessarily get all of them in the grid. It would be important in this one because we have endpoints, so we would need to plot all of them. So let's plot these points. So 0, 0, 1/2, 3, 2, 6, 9/2, so that's 4.5, and 9. So it's still that curved shape and there's an endpoint. So you want to make sure those endpoints are there and all 4 points are clearly plotted.